Hi everybody, so in this lecture we will solve exercise number 4. We have a function f defined by this expression, and first question is to find the domain of definition, then to find the limits at plus infinity minus infinity, then to set up the table of variation, and then to draw the representative curve of the function f. So the first question is to find the domain of definition. So the domain definition f is defined for all x belong to the set of real numbers r between minus infinity and plus infinity. The limits at plus infinity minus infinity. So first of all we will find the limit at plus infinity. Here, because of the function f is a polynomial, so it is sufficient to find the limit of the highest power, which is x squared. So limit at plus infinity when x tends to plus infinity for x squared is equals to plus infinity power 2, which is plus infinity. And similarly we have the limit at minus infinity of x squared, which is minus infinity power 2, that is plus infinity. So now first of all we will set up the table of variation, and then we will draw the representative curve. So f prime of x is the derivative of the function f. So the derivative of x squared is 2x. The derivative of minus 2x is minus 2, and the derivative of any constant is 0. Then this function f prime of x equals to 0 when x is equals to 1. So we will draw the table of variation. First we plug the domain of definition, and where f and the point where f prime of x is equals to 0. So at the right of x equals 1, f prime of x is positive, and at the left of the point plus 1, f prime of x is negative. So as we proved in part 1, the limit when x tends to minus infinity is plus infinity. We don't have here asymptotes. F prime of x is negative, so the function should be decreasing, and decreasing to the point of abscissa 1, which is f of 1, the maximum. F of 1 is equals to 2. Then the function f should be increasing because f prime is positive, and the limit is proved in part 1 at plus infinity, which is plus infinity. So we have function f starts from a point of abscissa minus infinity plus infinity, then decreases to the point of abscissa plus 1 and ordinate 2, then it increases to the point of abscissa plus infinity and ordinate plus infinity. So first of all, to draw the curve, we draw the y-axis, x-axis, 0, we have 1, abscissa 1, ordinate 1, and ordinate 2. So the second step is to plug asymptotes if we have. Here we don't have asymptote, but we have the maximum point, which is a point of abscissa 1 and ordinate 2, which is the blue point. And always the maximum points and the minimum points, we insert an arrow on the maximum and on the minimum, so that the curve is tangent at this point. And then we read the table of variation from left to right. So we should start from the first red point, which is of abscissa minus infinity and ordinate plus infinity, and then we should end at a point of abscissa plus infinity and ordinate plus infinity. So we start from the first red point, we decreases to the maximum, which is a point which is the blue point, and then from this point we increase it to the ending point, and this is the curve of the function f, which is c. Finally, please try to do this exercise as an homework.